Hey, good morning, physics fans. Well, maybe it's afternoon. I don't know when I'm seeing you, but or when you're seeing me. The virtual world. Well, anyway, some people have looked for some help in the Google Sheets realm, and I figured the best way to do it is to just drill in like a student. So I am in as my student account. You can see my little chicken icon, Major Tester. Yeah, he's in your class. It's me. Anyway, here's the virtual acceleration lab. There's a quick video. There's also an auxiliary video with more information and data on it. You've got the original assignment and you've got the lab rubric. What do I have to do? And we'll go through that in class. And then my copy of the raw data, which is where you need to get some support perhaps. So here we go. All right. It opens or defaults to the first tab, which is the photo gate, where you've got some more calculations to do. Maybe I'll do a separate tutorial just on that one, but let's go just to the motion sensor. It's a little less busy. It's just 30 values, and we need to do some work with that, right? It's just raw data, right? I ran the experiment 30 times, or other people did, or a combination, right? And there's our data set, right? And then we have three pieces of information that we need to dig out. So first is average, right? Average acceleration, and it's just good form to put the units, meters per second per second. You can't put that's one of the downsides of both Google and Excel. You can't put exponents or subscripts in inside. So you have to go meters per second per second. So there's our label, average acceleration. How do I make Google Sheets do math for me? I click in the box, I press the equal sign. Oh, beautiful. The thing is one step ahead of me. Yes, I would love for you, Google, to do the average for me. And then if it doesn't auto-populate, you can click and drag, or you can type in the address of the top and bottom cell of the column. Important piece, this operand here, this is a colon. If you put a comma, it only does the first and the last. You need to be a colon so it does all of them inclusive. And then you just hit enter. Boom, there it is. And then I go, I better fix the significant figures on this because this is a motion sensor. If I look at my sheet, motion sensor, it can do time to 4 digits. It can do distance to 3 digits. 3 is less, so I can report 3. Boom, fixed. There we go. Then the other piece of information we need is standard deviation. STDEV. Oh, right. I go over here, equals, look at that, one step ahead of me. Same range of values, cell 3 to 32. Boom. Fix my significant figures to also 3. Boom. This is not so bad. I think I can do this. And then relative error. Relative error. There's a separate tutorial on that. I'll probably put it with this for you guys. Just another explanation. It's also on the post from week 1 of class, making sense of numbers. The information from North Carolina University has the definitions and explanations also. Relative error expressed as a percent, which would be our units, which reminds me I should put my units. The units of standard deviation are the same as the value that you measured, so it's meters per second, or meters per second squared. Here we go. how do I get the relative error? So the relative error, right, is a measure of two things. Well, one, it's about what did we find, and that's right here in cell 35, right? So I'm going to go here and just say, okay, Google, do math for me, equals, open parenthesis, it's going to be what did I find, 0.687, minus, and then I happen to drop on each sheet for you. It's up a ways. There it is. There's the value. It's in E8. I'm just remembering the address. Minus E8, right? Divided by E8. What is the relative error? So compared to what? So I can either click that again, or I can type it in. Hit enter. There it is. Relative error. Oh, I forgot one thing, right? If that's expressed as a percent, I have to go star, right? Shift 8 times 100, right? And then the rule for significant figures for decimal is no more than 2, right? 1/100th of a percent is pretty small, so you don't report more than 2. There you go. There are the 3 pieces of data you need to find for each of the 4 methods to make a determination, right? What was the average value for your trials? What's the standard deviation? So that's telling me how did the data spread out, or was it all really close to that average, right? What's the shape of the bell curve that goes along with our data, right? And then what's the relative error? So that's this, right? So my target value is that 0.6424, right? That's the acceleration we expect mathematically on the ramp, right? So what did my average do? In this case, it looks like my average came out right here just a little faster, right? Because it's a positive number, right? And if I got a negative percent, it means that it came out below. And 7% is very small. Right? But those are the 3 pieces of information that you need to gather for this lab. So this is with you 24/7. Hope that helps. If not, you know where to find me. Block 2 or advisory/flex. Over and out.